let's have a discussion from the topic electrolysis. In your section A, the question, that is question number 6. Let me read the question. The question is, the amount of electricity that can be deposited 108 gram of silver from silver nitrate solution. The choices are 1 ampere, 1 coulomb, 2 ampere, 1 farad, like that. Okay. So you want to deposit 108 gram of silver from the solution of silver nitrate, and we know that in your silver nitrate the Ag plus exists, silver exists as Ag plus, and the reduction reaction will be Ag plus. When it gains 1 electron, what happens? It becomes Ag. Ready? Here the charge involved or the electron involved is 1, which means that we know that by applying 1 farad, 1 mole silver will deposit, right? Yeah. 1 mole silver means what? 108 grams silver. So perfect. So in order to deposit 108 gram, we want to supply 1 farad current. The choice is 3. Ready? Okay. Let's check the next question. And the question that is question number 18. Question number 18 in your section A. The question is that the number of Faraday required to deposit 1 gram. Number of Faraday are required to deposit 1 gram equivalent of aluminum from the solution of AlCl3. So we have a solution of AlCl3. Solution of AlCl3, and we need to deposit 1 gram equivalent of aluminum. 1 gram equivalent of aluminum. So how much Faraday is required? That is the question. Okay. So we want to deposit 1 gram equivalent of aluminum. We all know that 1 gram equivalent of aluminum means we want to deposit 1 or equivalent mass of aluminum. Equivalent mass of aluminum. Okay. To deposit equivalent mass of any substance, we just supply 1 farad. Okay. So equivalent mass of aluminum or anything, it requires 1 farad. Okay. Gram equivalent means 1 equivalent or its equivalent mass. Gram mole means 1 mole, like that. Okay. So your 1 farad is enough. Ready? Question number 18, the answer is 1. Moving to the next question. Moving to the next question. That is listen. Question number 19. Electrochemical equivalence of copper in the reaction. So the reaction is given Cu2 plus 2 electron gives what? Copper. And you want to find the electrochemical equivalence. What do you mean by electrochemical equivalence? Is that how you obtain the electrochemical equivalence? Equivalent mass of a particular substance to the 96500 ratio. Okay. So here the equivalent mass of copper, we know that the molar mass divided by N factor will be the equivalent mass. And molar mass is 63.5, and N factor, since it is a diatomic, dipositive cation, equivalent mass is 2. N factor is 2. So what will be the answer? 63.5 divided by 2 into 96500. Okay, I think the choice is 2. Okay, choice is 2. Ready? So the next question, that is question number 27. I think it is already discussed in the theory. 3 farad of electricity passed through a cell containing connected series. Okay, so 3 farad is passed. Ready? Through cells which are connected in series, which contains these ions, Ag plus, Ca2 plus and Al3 plus ions. Okay. Then the molar ratio liberated. This type of question is already discussed. Okay. In your theory. Yeah. Here the charge is 1, right? So 1 farad applied, 1 mole deposited. I think here 3 farad supplied. 3 farad supplied, 3 mole deposited. Here the charge is 2. So it becomes So it accepts 2 electron, which means the electron inward is 2. So 2 farad applied, 1 mole calcium forms. So 3 farad applied, 3 by 2 mole calcium forms. Here the charge is plus 3, which means that it should have accept a 3 electron. So the electron inward is 3 farad. Sorry, 3. So 3 farad applied means 1 mole deposited. Okay. So the ratio is 3 is to 3 by 2 is to, I'm sorry, one. Fine. 1. 3 farad applied 1. Yeah. 6 is to 3 is to 2 will be the answer. Okay. So choice is 3. Moving to the next question. The next question, that is question number 39. Which of the following statement is incorrect? Which of the following statement is incorrect? Number 1, the first statement, that is electron enters through cathode in an electrolytic cell. Number 1, electron enters to cathode in an electrolytic cell. Electron leaves through anode in an electrolytic cell. Cation in the electrolytic cell moves towards cathode and anions towards anode. Cation reduced at anode and anions oxidized at cathode. So the wrong statement is both one, right? Cation should be reduced at cathode and anion should oxidize at anode. So the first statement will be wrong. Rest is correct, I think. Yeah, electron enters through cathode in electrolytic cell. It enters through the cathode to the cell and it moves through the anode. Okay, and leaves through the anode. Fine. Question is okay. Rest is okay. Okay, so the choice is a knowledge-based question, and the choice is 39. The choice is 4. The very nearest question number 40. Okay, 40, that is the mass of chlorine produced when 1 amps current is passed through NaCl solution for 30 minutes. Okay, so we want to find the mass, and we know the equation W equal to ZIT, or it is replaced using the formula E by 96500. So E by 96500 of IT, right? Yeah. So the species given is NaCl, and you want to find the mass of chlorine. So chlorine liberated means will be like this, right? Yeah. So what is the equal mass of chlorine? Since the charge of chlorine, since chlorine is monatomic ion or mononegative ion, it's in n factor is 1. So equivalent mass of chlorine will be equal to molar mass divided by 1. So which means 35.5. Okay, 35.5 is the equivalent mass of chlorine divided by 96500. You want to find the weight deposited, right? Yeah. And the current passed is 1 amps current. It is for 30 minutes. So 30 into 60. Ready? Okay. So the mass of chlorine is asked. Let's bring 1 divided by 96500 to the top. It becomes 1.04 into 10 raised to minus 4, right? Yeah. 35.5 into 30 into 60. 3 into 6. If 2 zeros enters to here, it will be minus 3. Okay. And this is 18. So 18 into 1.0804 will be 18. That is 18.72 into 35.5 into 10 to the power minus 2. So approximately 19. So 35.5 into 19. Okay. 5, 4, 5, 9. 4 is here. 9. 27, 31, right? Yeah. 5, 5, 3. 5, 4, 7. Ah, 6. So into 10 raised to minus 3 means 6.745. already it is a 35.5. So here is the point, okay? Into 10 raised to minus 3 means 0.695. So you can choose the choice as 0.66. 0.66 gram will be the answer. Ready? Move to the next question. That is question number 42. Question number 42. Okay. So in your question number 42, a current of 9.65 amps passed through 10 means deposited weight is 3. You want to find the equivalent mass. So direct question. So we know that W equal to E divided by 96500 of IT. So you want to find equivalent mass. The weight deposited is 3. 3 gram is deposited and should find equivalent mass. Here it is 96500, but the current is 9.65 amps. Agreed? Yeah. And it is passed for 10 minutes. So 10 into 60 seconds. Okay. Fine. 0, 0, 0, 0 cancelled. And 9.65, 965 cancelled. Here is the 100. Okay. So in top it is 6. So 6 divided by 100 into E, which is equal to 3. So this is 2. Okay. So E is equal to 100 divided by 2, which means equivalent mass is 50. Equivalent mass is 50. So choice is 3. Okay. So what about the next question? The next question, that is question number 48. Question number 48. Listen here. In question number 48, if 9 gram of water is electrolyzed with completely with 50% current efficiency, so how much current is needed? That is the question. 1 farad needed, 3 farad needed, 4.6 liter oxygen STP formed. Fine. Anyway. Mm. Nine gram water means what? Half mole of water. Yeah. Okay. So in the electrolysis of water, this will be the electrolysis reaction, right? Okay. So it is clear that in the electrolysis of water, the electron involved is 2, which indicates that when 2 farad current passed, 1 mole water electrolyzed. Agreed? Agreed or not? Agreed. So in the case of reduction and in the case of oxidation, the electron involved is 2, right? So which means electron involved is 2 means okay. So it actually requires 1 farad. Okay. So 1 farad applied, 9 gram water electrolyzed. 1 farad applied, 9 gram water electrolyzed. But you have to note that here only the current efficiency is what? Here the current efficiency is 50%, which means that if you supply an input of what? If you supply an input of 1 farad, sorry, if you want to get an input of 1 farad, you should supply 2 farad, right? If you supply 2 farad, then the output will be 1 farad. Okay, since the current efficiency is 50%. So listen here. Actually, 1 farad enough for 9 gram, right? But current efficiency is 50%. Therefore, you supply 2 farad. You want to supply the double amount. Then only you obtain the expected one. Okay. So here actually for 9 gram, you want to supply, or you should supply 2 farad. But the 2 farad is not in the question. 2 farad, 3 farad. Sorry, 2 farad, 1 farad, 3 farad are the 1 and 2 choice. So that is not the choice. What about the next? 5.6 liter of oxygen at STP. Listen here. Here, O2 minus become half O2 plus 2 electron, right? If 2 farad supplied, half mole O2 liberated. Half mole O2 liberated means 11.2 liter oxygen liberated at STP, right? Farad supplied means 11.2 liter oxygen liberated in a normal case. Okay. But since the current efficiency is 50%, if you supplied 2 farad, then output for 1 farad. And what do you obtain? You obtain 5.6 liter of oxygen liberated at STP in this question for the application of 1 farad. Okay, so it is enough. Ready? Okay. So moving to the next question. So the choice is 5.6 liter. Okay. Moving to the next question. If the density of copper is 8.94 gram per centimeter cube, the number of Faradays required to plate an area of 10 into 10 thickness of 10 raised to minus 2. It's a good question. Listen. So here is an electrolysis process. Okay. So the solution taken is copper sulfate. Copper sulfate contains Cu2 plus, and you want to plate a copper. You want to plate a sheet with the copper, I think. Yeah. And the area of the plate is given as 10 into 10 centimeter. 10 cross 10. Okay. And for the thickness 10 to the power minus 2 centimeter, which indicates that the volume is, we know the volume is area into thickness. Area is 10 into 10 length into breadth, and the thickness is 10 to the power minus 2, I think. Yeah. So will be 1 centimeter cube will be the volume. 1 centimeter cube means enough. And here is a copper electrode which taken as anode, and you know the electroplating. From anode, Cu becomes Cu2 plus, and that Cu2 plus deposited on the cathode, so that the coating is, or the plating will be okay. Listen, and the density is given here. The density is 8.94 gram per centimeter cube. So we know the density of this material, and we also know the volume of this material, so we can easily find the mass that is deposited, right? Yeah. Mass is equal to density into volume, right? Yeah, density is equal to mass by volume. So mass by volume, so density into volume will be mass. What is the density? 8.94 gram per centimeter cube, and the volume is 1. So the mass you want to deposit is 8.94 gram. and you should calculate the number of Faradays of current. Okay, in the case of your copper, right? So we know that W is equal to equivalent mass divided by 96500 of Q. Okay. So the W here is 8.94. Equivalent mass is 31.75, I think. 63.5 divided by 2 in the case of copper. Okay. Divided by 96500 into Q. Okay. So you should find this answer in terms of farad. So this is simply taken as 1 farad, right? Yeah. So 1 farad to here and 31.75 to here. So the charge is, tell me, 8.94 into 1 farad divided by 31.75. 8.94, 31.7. Simply if it is 29, sorry, 9, 3 times will be okay. .94 into 4, what it is? 6, 1. 36, 37, 3. 32, 35. Not okay. So what about 0.28? 0.28. Let's check it is 0.28 or not. Question number 51. Yeah, this is correct. So there is a rough approximation. 0.28 farad will be the answer. The concept is clear, but actually I think the choice is 0.3 something. It is not given, and they given that it is 0.28.